So we will now proceed to problem number 2. Given the equation y double prime minus x over 1 minus x squared to the power of 3 halves is equal to 0 with the condition y of 2 is equal to 0 and y prime of 2 is equal to 0. So the given equation is just equal to y double prime is equal to x over 1 minus x squared to the power of 3 halves. So we will integrate both sides with respect to x. So y prime is equal to integral of x dx over 1 minus x squared to the power of 3 halves. So we will let u here as equal to 1 minus x squared. Negative du over 2 is equal to x dx. So by substituting this dollar data into the integrand, we will end up with y prime is equal to negative 1 half integral of u to the power of negative 3 halves du. So y prime is equal to negative 1 half u to the power of negative 1 half over negative 1 half. So cancel, plus c1. So our y prime is equal to 1 over square root of 1 minus x squared plus c1. We will again consider this equation as equation number 1. Where our C1 here is an arbitrary constant. But since it is given the condition that y prime of 2 is equal to 0, then we can solve for the value of our C1 here. So by substitution, we have 0 is equal to C1 minus imaginary over square root of 3. So C1 is just equal to I over square root of 3. So the equation for y prime is equal to 1 over square root of 1 minus x squared plus I over square root of 3. So we will now proceed to get the value of y. So integrate both sides with respect to x. So we have y is equal to integral of 1 over square root of 1 minus x squared plus integral of I over square root of 3 dx. And this is also dx. So by calculus, in integrals yielding inverse triangle functions, we will end up with y is equal to sine inverse of x plus I square root of 3x plus c2. We will again consider this equation as equation number 2, where our c2 here is an arbitrary constant. But again, since it is given the condition that y of 2 is equal to 0, then we can solve for the value of our c2 here. So again, by doing substitution, we have 0 is equal to sine inverse of 2 plus I square root of 3 times 2 plus c2. So by transposition, we now have the value of c2, which is equal to negative sine inverse of 2 minus 2I square root of 3. Since we already have the value for C1 and C2, we now have our final answer. So our final answer is y is equal to sine inverse of x plus I square root of 3x minus sine inverse of 2 minus 2i over square root of 3. This is now our general solution for the given equation.